Now, once again, our goal is to construct this MST T prime, which contains X and E star. Now, we know there is an MST T, which contains X. Now, there are two cases to consider. Either this edge E star is a part of T, or it's not part of T. Now, the easy case is suppose that E star happens to be part of T. Then in this case, what is T prime? T prime is the same as T. There's nothing to do in this case. Notice we have that X is part of T. And we're supposing that E star happens to be part of T as well. What's our goal? Well, our goal is to show a tree T prime, which is an MST. Well, T is an MST. So if we set T prime to be T, then we have that T prime is an MST. And we know that X is part of this T, or T prime, and also E star is part of it. So we have that X union E star is part of T prime. So there's nothing to prove in this case. Done. So the hard case is, what if E star is not part of T? In this particular example, this E star is not part of this particular MST T. So what do we do in this case? Well, we have to modify T in order to add edge E star into T and construct a new MST T prime. How do we construct this tree T prime in this case? Well, let's take this tree T, which contains X, and let's add in the edge E star to it. So let's look at T union E star. So we're taking the red edges in this graph, and we're adding in this edge E star. Let's say that the endpoints of E star are A and B. Now T is a tree. What happens when we add an edge to this tree? Well, it creates a cycle. It's going to be a cycle which contains this edge. Now this tree contains another path between A and B. The path between A and B in the tree T goes along here, along the blue edges. And then when we add in this edge E star, we get a cycle containing edge E star. Let's call this cycle C. Now I want to drop an edge from this cycle in order to make a tree T prime. Now we'll show that we can drop any edge from this cycle and we'll have a tree T prime. But we want it to be a minimum spanning tree, so we want the weight of T prime to be minimum. How do we show that it's a minimum weight spanning tree? Well, we know that the weight of T is minimum. So if we show that the weight of T prime is the most the weight of T, then T prime is also minimum weight. So we need that the edge that we drop has weight at least that of E star. Now which of these blue edges has weight which is at least that of E star? Well, what was special about E star? E star was chosen to be the minimum weight edge across this cut, S bar. Now in this particular example, there are three other blue edges crossing this cut, S bar. So what do we know about these three blue edges crossing this cut compared to E star? We know that the weight of E2, E3, and E4 is at least that of E star. So we can drop any of these three. So we take any of these three edges, let's call it E prime, which is in the tree T, and which crosses S to S bar. Now in this example, once again, there are three edges crossing this cut, S bar, which are in this tree T. Now in general, why do we know that there's an edge E prime, which is in the tree T, which crosses S to S bar? Well, this edge E star has one endpoint in S and one endpoint in S bar. Now this tree T, it's a tree, once again, so that means it's connected. So that means there's got to be at least one path between A and B. Now that path has to cross from S to S bar at some point. Now in this example, it crosses multiple times, but it's got to cross at least one time from one side to the other side. Now when it crosses from one side to the other side, it has to have an edge which crosses from one side to the other side. So take one of those edges which crosses from one side to the other side. Call that E prime. And finally, we have our tree T prime. We're going to set T prime to be T, which is the MST which contains the partial solution X. We're going to add in this edge E star, which is the edge we're trying to add into our partial solution. And then we're going to subtract, we're going to take away any edge which crosses from S to S bar, which is part of this tree T. And we know there exists at least one such edge E prime. Take any such edge E prime and take it out of the tree T, add in the edge E star, and this gives us our tree T prime. Now what remains? Well, we've constructed this T prime, and now we have to prove that T prime is in fact a tree, and that it's a minimum weight. Therefore, it's a minimum spanning tree.